Hello, everyone. I'm honored to be able to introduce my work on such a special receiver. The topic of the paper I will speak to you is a cloud survival architecture for SDN-based Space-Terrestrial integrated network. So, I plan to introduce my paper from the following three aspects. First, I plan to introduce the research background of this paper. Next, I will describe the main research work of this article from several levels. Finally, I will draw conclusions. Okay, let's start the first part of the narrative. As we all know, with the rapid economic development, the scope of human activities has spread all over the world. However, there is a problem that the terrestrial network has a limited coverage area and cannot meet the needs of global coverage. Naturally, people thought of using satellite networks to make up for the lack of coverage of terrestrial networks. But the satellite network is far away from the ground. Its transmission delay is extended, and the connection is unstable. Therefore, it is an inevitable demand to find a unified architecture and combine the advantage of the two networks. So, this paper proposes a new network architecture that can realize the integration of satellite networks and terrestrial networks. It can realize unified schedule and efficient management. Next, I will briefly introduce the current status and challenges of terrestrial and satellite networks. At present, the terrestrial networks and the satellite networks are still independent of each other, rather than complementary forms, which are responsible for different application scenarios. But we don't hope this. At the same time, the satellite network changes quickly, and the exciting technical means are not mature enough to effectively solve the heterogeneity of the network itself. That is what we have to challenge. Then, let's move to the solution part. First, I will introduce the overall architecture of this paper use SDN to manage the network. So, what is SDN? SDN technology is an approach to network management that enables dynamic, programmable, efficient network configuration. It is in order to improve network performance and monitoring, making it more like cloud computing than traditional network management. Look at this figure. This is the SDN structure. So, you can see it includes three layers: application layer, control layer, infrastructure layer. And this is all unified deployment through SDN controller. This is the SDN-based network convergence architecture. Look at this figure. It is mainly composed of the space-based backbone network, the space-based access network, and the terrestrial network. All three networks are different. So, the different networks communication through inter-satellite links and satellite-to-earth links. The SDN controller is the brain of the network. It is responsible for the unified forwarding, distribution, and processing of communication information. Subsequently, I will describe the three networks in detail. First, look at this picture. The space-based backbone network consists of geo satellites, which interconnected by a laser link. It is responsible for connecting the satellite nodes in the network and can be used as the SDN controller, which analyzes and forwards the commands issued by the ground data center and transmits commands to the mail or low orbiting satellites. In addition, with the large storage and computing of geo satellites, it maintains the flow of tables in the network and manages all flow tables. When a data packet comes in from the ground data center or the space-based access network, the data packet can be routed to the location according to the start flow table information. So, for different quality of thread requirements, the space-based backbone network can also choose to forward the incoming data after preliminary processing. This is effectively reduce the load on the link and can improve the quality of thread. This is the space-based access network. The space-based access network is mainly composed of mail or LEO satellites, compared with geo satellites. Medium and low orbit satellites are closer to the ground. This advantage makes them have lower transmission delay, and there are less information loss during transmission. Therefore, it is a suitable choice for the space-based access network. The LEO satellites are composed of communication, navigation, and remote sensing satellites. The location, weather conditions, and other information of the access user collected through the satellite provide the access user with opposite channels and network reservoirs to maximize the use of reservoir rates. At the same time, the MIL or LEO satellites can act as switches for the entire SDN architecture. Next, the terrestrial network composed of the existing network, such as mobile Wi-Fi, which together with the satellite network forms a communication network with global coverage. It is interconnected by optical fiber links to form a unified data center, in which data can be forwarded and stored. So, to facilitate the management of the integrated network, the SDN is used to separate the control plane and the data plane. And operations such as the distribution of the flow table are realized through the SDN controller and the open flow. NFV technology is also used to map the network reservoirs into a visualized reservoirs pool, and the network is managed uniformly through the SDN controller to realize real-time monitoring and control of the network schedule. Based on the information monitored at different moments, the SDN controller can dynamically adjust the network resource allocation pricing, routing path selection, and realize dynamic configuration management of the network. Now, I will introduce the cloud swap architecture proposed in this article. as we all know. The article is a typical 4-tier architecture system with the help of visualization, cloud computing, and other technologies. We highly integrate the resources of the two networks to form a unified resource pool for deployment. The two networks are the satellite networks and the terrestrial networks. At the same time, it radiates to form a platform layer and an application layer, providing different services for users with different needs, such as navigation, weather conditions, etc. Finally, let me make a summary of the proposed architecture. First, the architecture realizes the global coverage of the communication network. With the help of satellite networks, it effectively compensated for the shortcoming of insufficient coverage of terrestrial network. It makes making it possible to providing network service to users in area where terrestrial-based stations cannot be deployed, such as oceans and deserts. In some instances, when encountering natural disasters such as earthquake, even if the ground network is destroyed, the satellite networks are still available to realize the communication, navigation, and other services to distressed area. This is greatly improved the quality of service. This above is all the introduction to my paper. Thank you for your attention.